I also realized I misspoke earlier when I was talking about model size. So as these models get bigger, these kinds of things, like something that could act as an oscilloscope over the whole network, as opposed to having to individually probe yourself neuron by neuron or layer by layer. I said that some of the biggest networks like GPT-4, I think I said 1 to 2 billion. The 1 to 2 trillion is where we're at now. Um,
Yeah,
and so, yeah, so,
we could also clarify like number of parameters versus number of
neurons. That's right. Yes, of course, of course, of course.
very,
Selenium.
very big networks. That was the point.
Yeah, and it's funny, I do that embarrassingly often where I kind of interchange between parameters and neurons when you can have orders of magnitude more parameters trivially relative to the number of neurons. And often I am quite aware of that fact. I mean, obviously when I'm working through the math or when I'm building a network, but it's funny how we can use it interchangeably. And you often catch people in arguments, say talking about AGI, they'll say, we now have a network with 2 trillion artificial neurons. The human brain,
Yeah.
or sorry, yeah. So there's really there's 1 to 2 trillion parameters connections.
I think neurons, if to a lay audience, is easier to map to the concept of a brain.
Yeah.
Parameters, which I guess you could say is like connections, like dendrites or something.
Exactly. Yeah, but then you're starting to really get into some. You'd have to like at least have 5 minutes of neuroanatomy before explaining. So you end up in the situation where, yeah. So you have like there might be about 2 trillion parameters in GPT-4, and not all of those are active on a given call. So it seems like there's 8 kind of based on the rumors. You have these 8 expert networks in this mixture of experts. But anyway, you have that many, say 2 trillion parameters, but the number of neurons could be many orders of magnitude fewer than that. Anyway, I'm kind of off on a on an unnecessarily technical tangent.
It's hard to talk about in a convolutional network. It's almost like the neurons are replicated in space, so are they unique neurons or not? In a transformer, the neurons might be applied at every single token. Are those the same neuron or not? So even using these words is underspecified.